Hey guys, and welcome back to another video on the channel. In today's video we're going to be integrating this following one, the integral of 3 sine x plus 4 divided by 3 plus 4 sine of x all squared. Now this is a very hard integral at the start, mainly because you can see these terms are almost the same, it's just the numbers are flipped. And of course there's a squared term here. So what we're going to do with this integral is actually something a bit weird. What we're going to do is actually divide top and bottom by cos squared. Now you can do that because technically I can times it by 1. So what I mean by that is I can times it technically by 1 on cos squared and 1 on cos squared. Because technically I can rewrite this whole thing as 1 on cos squared divided by, tip and times that, times by cos squared, oh that's a terrible looking squared, cos squared x, which cancels out to 1. So this is a valid substitution you can make. Now if we do that, what we're going to do is get a bit of an algebraic mess, but we'll slowly break it down. So the integral of 3 sine of x plus 4 on cos squared x divided by, what was the bottom bit? Oh, there it is. 3 plus 4 sine x all squared divided by cos squared x. Now what I'm going to do is actually just break it up into parts and do them separately. So I'm going to rewrite this guy over here. So we'll have 3 sine of x plus 4 on cos squared of x. And you're probably wondering why I'm changing this, because at the start we wouldn't be able to do a u substitution, so we've got to pretty much change how this function looks using trigonometry. So if I get this guy here, if I apply the division, this can be rewritten as 3 sine x, let's move that to the side, over cos squared x plus 4 over cos squared x. Now we're going to rewrite the cos squared as sec theta. So cos squared, well 1 over, is sec squared x, because 1 over cos is sec. So 1 over cos squared is sec squared. So I can rewrite this bit as pretty much, we can actually rewrite this actually a bit easier as well. Sine x all over sec x, and still have a cos down here, and the reason why I'm going to do that is because then I can make this substitution for sine. So all I did was take this cos squared and just rewrote it as, alright, cos squared is just cos x times by cos x. So this statement here, what I actually have, if I move this to the side real quick, this here is equivalent to pretty much just 3 on sine x on cos x times by 1 on cos x. So that was the working I did to get down to here. Now I'm going to rub this out because it's in the way pretty much. So that's what I did there, just to make things a bit neater. Now the reason I wrote it like that is because then I can actually rewrite this whole thing as tan x. So this can be rewritten as 3 tan x sec x. I can now move this guy closer because I'm done doing that stuff. Draw that bracket there, and I can rewrite the 4 on cos squared x as just 4 sec squared x. Nothing too fancy like that. So basically this entire thing, if we move this entire trigonometric statement just turns into 3 tan x sec that's a C, sec x plus 4 sec squared x. Now you're probably wondering, why did I do that? Well, we're going to do some stuff down here as well, and something very nice is going to happen. So now we're going to look at this bottom statement here. So we have pretty much 3 plus 4 sine x, this is all squared, on cos squared. So there's no reason why I can't take the squared outside pretty much, because they're both squared terms, so why not just remove that from both of them and just put it on the outside? So that's a valid substitution. And why don't I just distribute the cos as well? So I'll have 3 on cos x plus 4 on sine on cos is tan x. And then I can rewrite this bit as sec as well. So we have 3 sec x plus 4 tan x. Okay? So hopefully you can see what I've just done there. Now I can rewrite this whole integral now. So the integral of pretty much 3 on sine x plus 4 on, what was it, 3, oh yeah, it was the other way, plus 4 sine x all squared. I can rewrite this entire integral pretty much like this, because all I've done is replace the top with, what was it, this guy up here. So 3, why is that red? So 3 tan, I'll write the integral sign in a second as well, tan x and sec x plus 4 sec squared x all over this guy, which we just wrote over here, which was 3 sec x plus 4 tan x all squared. Now, if you don't notice this, we're going to do a u sub now, because if we differentiate this green term, it's going to be exactly equal to this guy here. Because, let's just do that real quick. If you differentiate sec x, that turns into tan x, sec x. And if you differentiate sec squared, that turns into, oh, not sec squared, sorry, I was looking at this top term here. If you differentiate tan x, that turns into sec squared. So, if I let u equal this green bit here, so I'll go let u equal 3 sec x plus 4 tan x, and I want my du, so du, differentiate this side, this turns into 3 tan of x, sec of x, plus 4 sec squared of x dx, which is just brilliant, because if you substitute that guy up here, it's going to cancel out very nicely. Because if I rewrote this in terms of dx, dx is du all over this pretty much. Sec x plus 4 sec squared x. So our integral that we just wrote here, the integral of 3 tan x sec x plus 4 sec squared x, it's very hefty, this integral, all over, now what was it? It was this guy here. 3 sec x plus 4 tan x all squared dx. If I let this equal u, I can replace that with just a u straight away. So if I do that, that'll be u squared. But I've also got to replace this dx with this term here, pretty much. So all I got to do is rub that out, and literally just substitute that guy in there. So we can see that whole thing cancels with that whole thing, and we're just left with pretty much the integral of du on u squared. We can rewrite as u to the negative 2 du. Therefore, add 1 to the power, divide by the new power, so you can get u to the negative 1, negative plus c. Don't forget the plus c because there's no bounds in this one. So it's going to be negative 1 on u plus c. And we decided what u was. U was this fella up here. So all I'm going to do is copy that. And I'll get rid of the color as well. And we might keep it. Oh well. And just bring that fella down here. So get rid of the u now. And extend that. It goes under there. Plus c, move that a bit closer. And that, if I extend the fraction is our answer to the following integral. The integral of 3 sine of x plus 4 on 3 plus 4 sine x all squared dx. That is the answer. Hopefully you enjoyed that video. If you have any questions about anything here, leave some in the comments and I'll try my best to answer them. If there's any integrals you want to do particularly, send me an email and I'll pretty much cover it. Alright, I hope you enjoyed this video. I'll see you in the next one.